actual titration problem. So a student titrated HCl, and the HCl has an unknown concentration. Now HCl, we see this on table K, so we know that this is the acid. So the unknown concentration, what we're solving for is the MA. So we know so as soon as we see in a problem, soon as we see something about titration, we need to think MAVA equals MBVB, right? So right away, I'm going to write down molarity of the acid times the volume of the acid equals the molarity of the base times the volume of the base. And according to what we just read, this is what we are supposed to solve for. So based on the reading and the data given, we know the VA, the MB, and the VB. So when we continue reading, the HCl with the unknown concentration was titrated with 0.75 molarity NaOH. Well, NaOH is a base, because we see that on our table L. So this is the base, and we see that number, so we know that that represents MB. So we know what to stick in there for the MB. Determine the concentration of the HCl based on the student's data. Well, they used a burette, and they took reading 1 and reading 2. So this is where the volume of the HCl started, and this is what they allowed to flow out. So we have to calculate the VA, and it's the difference between these two. So so to get the VA, we have to calculate the difference between where the volume started and ended. So when you put that into the calculator, that would be 5.19 milliliters for the VA. Now, they also used a burette to monitor the amount of NaOH, the base. So in the other burette, the volume started at 15.35, it ended at 26.42. So when we calculate the difference between where the meniscus started and ended, the volume of the base used in this lab is 11.07 milliliters. So now we know what to put in for VB. So let's first get our correct numerical setup done. So make sure you're showing your correct numerical setup. So for MA, that is our unknown. That's what we're solving for. So the unknown molarity of the acid multiplied by its volume of 5.19 milliliters equals the molarity of the base that we're pulling from the word problem that was given to us, 0.75 molarity, multiplied by the volume of the base, which we determined to be 11.07 milliliters. So now that we have our correct numerical setup, now simply multiply 0.75 times your 11.07 and divide the product by 5.19. So when you put this into your calculator, you end up with a molarity value of 1.6 M. So that would be the final calculated answer.